Okay, so unfortunately, derivatives don't always exist. Remember, limits didn't always exist. And there's particular cases where our derivative won't exist. So derivatives do not exist at the following. Sharp corners, jumps in the graph, where else? Asymptotes, vertical asymptotes. Okay, so sharp corners. So basically, y equals the absolute value of x. There's a case where we have a sharp corner. If we are looking at that function, it looks like a V. And so in this case, at x equals 0, the derivative does not exist. And that really is because it really depends on where you're choosing your h value. So remember I was saying, oh, normally I choose h where I pick it to the right of a. So if my a value here is 0, and I pick a value over here and look at that limit as h goes to 0, it depends on my function. Actually, let's just look at this. So recall, if we have f of x equals the absolute value of x, there's two separate equations that we use depending on what value of x we use. This is actually a piecewise function. This is equal to, well, if x is a positive number greater than or equal to 0, basically I would get back the same number I plug in for x, right? So if I plug in 2 for x, absolute value of 2 is just the number I plugged in, which is 2. Where if I plug in a number less than 0, I have to take the opposite sign, because the absolute value of -1, it's the opposite sign. It's negative of -1, which is 1. It makes it positive. And so this is, in this case, is negative x. If we look at this, though, and we want to look at the slope at x equals 0, it really depends on, did we choose 2 points over here on the right of x equals 0, or did we choose 2 points on the left of x equals 0? So if I look at this, the limit as h approaches 0, and I have this f of x plus h minus f of x all over h. Then, and x is greater than 0, or we're choosing something to the right of 0, then notice that when we plug this value in, well, whenever we plug in x plus h, it would go in here. So this would equal the limit as x goes, h goes to 0. Plugging in x plus h, wherever you see an x, you got x plus h minus f of x. So let's plug in x minus x all over h. And so let's simplify. Notice the x and the negative x cancel. So this is the limit. H goes to 0 of h over h. And that is equal to 1. So it makes sense if you look at this side of the graph and you found the slope between 2 points, that slope is 1. The problem is, so this is where we chose to add h. What if we were looking over here where h is here? And instead, this time, we're coming in this direction. If we're coming in this direction, we're actually using this piece of the line of the graph. And so then, if I did that, so really, this point right here that I'm looking at, this is a minus h. So if I go back in here, I'm using the second equation. And so doing that, I'm going to have negative, plugging in the x plus h, minus, just plugging in, so negative x all over h. So let's distribute our, I forgot my limit outside. So if I distribute this, this is where I get negative x minus h. Negative of negative is plus x all over h. And so negative x plus x, those cancel. And so we have the limit as h goes to 0 of negative h over h. Those simplify to equal the limit as h goes to 0 of negative 1, which is negative 1. If you look at this, the slope over here on this line, if we chose points getting closer and closer to 0, it's negative 1. It's decreasing. And since the slopes are not the same as we're coming into that value, that's why it doesn't exist, just at x equals 0. So sharp corners could give us different slopes, depending on which side you're choosing the value as we're approaching that x equals a as h goes to 0. Different slopes. So that's why the derivative does not exist there. So same sort of idea, right? If we were looking at a jump in the graph, my slope coming in on this side is going to look something like this.
Professor,
Uh-huh.
do you think you could maybe like zoom it out a bit or go up a little for me, please?
Yeah. So notice that here, if there's a jump in the graph, that depending again where we're choosing our points, where h is getting closer and closer to 0, that limit is not, that value, that slope is not the same. So there's just another example there. And then one other thing that we have to say is where the slope is vertical. So the derivative also does not exist when the slope is vertical. So you might get some function that kind of might look vertical for a little bit. And so in this area right here, remember if you have vertical line, the slope was undefined. And so that's what's happening here. So derivative does not exist. Well, and asymptotes, basically, remember asymptotes were values where our function was undefined. Vertical asymptotes. So we might have some graph that's coming up like this. We might have something on the other side that's going downwards. We might have them going in the same direction. But notice as you're getting closer and closer to x equals a, well, first of all, if f of a doesn't exist, f prime of a is not going to exist. It's undefined. And so the function has to be defined at that value in order to have a derivative there. Any other questions? So I'm going to stop the video and we'll take a break.